Good morning to all of you. So, welcome to the last day of CODS-COMAD. So, we have a keynote talk this morning by Anajana Susarla from Michigan State University. She's going to talk about, is seeking information on social media harmful to your health? Using AI and ML to understand patient education needs on social media. It's my privilege to introduce Anjana to you. Anjana holds the Omura Saxena Professorship in Responsible AI at the Broad College of Business. Her research interests include the economics of information systems, social media analytics, and economics of artificial intelligence. Her research has received grants and funding from several institutions, including the National Institute of Health, and she has been a very well sought after speaker in several forums. I welcome Anjana to this morning to give her keynote talk. Over to Anjana. Yeah.
Thank you for that wonderful introduction. Good morning, everyone. It's too bad I can't be there in person. Today, I'm going to be talking on my research, which is using social media to understand patient education needs. So, this work is has an interdisciplinary flavor. It's a collaboration between some folks in health informatics area, me, I'm in a business school, but I study AI and machine learning. And it's also a collaboration with folks in public health. And we have worked with a lot of doctors and patient education experts. And so this is, uh, I would say, first of all, it's our focus is more applied AI for social good. And second, I think we try to combine methods from a variety of fields. So I know this is a data science conference. So some of our methods are more application rather than we want to use the latest and greatest state of the art machine learning methods. So our emphasis is really on applying machine learning for social good. So let me talk a little bit about the problem motivation. For the past few years, in the era of COVID, it's almost that we are seeing a sort of a perfect storm, if you will, that there are all these chronic conditions at the same time. Social media has almost fueled the sort of what some are calling an infodemic, epidemic of false information or echo chamber kind of effects. And these have had some bad consequences maybe in public health with respect to creating public health failures. In the United States, there is a lot of conversation, for example, about low vaccine uptake, especially for some of the booster vaccines for COVID variants. And the most recent, I think, example where social media has played, some would say, an adverse effect is there was if you follow American football, which is they one of the players actually faced some collapsed during the game, and then there was a lot of false information about the vaccine caused this collapse type of thing. So how does that impact? What is the problem that we are trying to study? There is almost a vast amount of user generated content, and if harnessed properly, sites such as YouTube, billions of people all over the world visit these sites. There is some very useful content, there is some really misleading content out there. Can we actually find a way to credential, provide authentication of medical information or providers of medical information, so that at least that's one tool for the public to tell the difference between a credible source and a not credible source of healthcare information? How do we start solving that problem? So our approach is kind of using AI and ML as a sort of a digital therapeutics for health literacy. So that is, we use a digital and online health technology as something that can be used to treat a medical or psychological condition. And we have an automated solution wherein we can basically run thousands of videos through our platform, which I will discuss the technological details in a bit. And basically, we are using machine learning methods to evaluate these videos from publicly generated content on social media, such as we take YouTube as our example. Can we take these, can we evaluate them from a health literacy and patient self care perspective? And what is the end goal? The end goal could be something like you go to the doctor. The doctor says, in addition to whatever prescription that the doctor gives you, what if the doctor can find usable health information from the videos that are out there and deliver them as a prescription? In addition to physical prescription, you get a digital therapeutic prescription. And how does that help? There are a lot of public health interventions that have shown that if patients get information in video format, which is actionable, valid, just in time, and understandable, then the adherence to medication and patients' ability to self manage their condition, patient self efficacy, and patients feel more empowered in their conditions. I think that's our end goal, and that's what we are trying to do. And a lot of what I will talk about is how can we automate these methods? So, how do we automate the methods? What is the first problem? First problem is that whenever we see any of these platforms, it can be something like TikTok, which is very popular in the United States. It can be something like Instagram. It can be YouTube. These platforms are almost an endless loop of attention. The algorithms prioritize engagement and view time. So it's like when we start watching those videos, there's almost like a rabbit hole of a lot of content that's out there. So the problem is that of scale. How do I find any approach where I want to validate medical information, for example? How can I scale my method to address the really thousands or millions of videos that are out there? This slide shows an example from a study that was published in the Journal of American Medical Association, where doctors actually watched videos and did a content analysis of YouTube videos that evaluate immunization. So there is a lot of false information about vaccination, which is one of the big public health debates in the United States. And notice something, the number of videos that if you ask doctors to watch YouTube videos, they can watch maybe 20 videos or 30 videos. How can I take this kind of a very intense, in depth analysis? How do I scale it to thousands or hundreds of thousands of YouTube videos? That is the first challenge I'm trying to solve. And what is the second challenge? What's How do I define credible information on YouTube? These are some examples of recommendations on terms of YouTube content. There's again a lot of debate in the United States about, are content sites like YouTube, are they ending up sort of radicalizing people? How do we find online extreme content, for instance? So the problem then becomes, what is credible information? When we talk about health, who are the credible sources? Public doesn't understand agencies. Dr. Fauci, who is actually works for the National Institute of Health indirectly, people think he's the head of CDC. He's not. CDC is supposed to make vaccines, which they don't. And vaccines are not approved by CDC, they're approved by the FDA in the United States. So Dr. Vivek Murthy, who is the Surgeon General of the United States, actually put out this call for asking social media companies to be more responsible and asking the public also to be less credulous when it comes to how we engage with healthcare related information on social media. So, my co author for the work I do is also one of the people who is on a National Academy of Medicine convened a task force. And she's one of the people in that task force. But in the again in the United States, one of the initiatives has been, can we have researchers, including social media researchers and AI and machine learning researchers, in collaboration with doctors and public health experts? Can we put out a set of best practice guidelines for social media companies? And that is part of the work I'm going to talk about next. So how do we come up with these guidelines? And I also have written a lot of articles on this subject, so I just want to quickly mention. So how do we assess medical information understandability? There are a lot of gaps. So how do we understand how users are interacting with information? What are the scientific, can we have social media companies work with people such as myself? And that's the National Academy of Medicine task force that I talked about. So how do we understand content that is medically relevant as well as understandable from patient education perspective? What are some methods? So we collected data from YouTube, and what we tried to do is to approximate how people actually find information on YouTube. So we started with one chronic condition, diabetes. And then, of course, we scale this for many different conditions. We have collaborations with Harvard Medical School. We have collaborations with people from University of Pittsburgh Medical Center, from Mayo Clinic, various other organizations such like that. And what we have, starting with diabetes, we explored a lot of conditions like COVID. Um, we've also explored public health problems such as and also diagnostic procedures and so forth. So let me start with the first research study, where we started with studying diabetes. We want to understand how people actually discover content on YouTube. So, what do we do? There is a question and answer forum for diabetes called Daily Strength, where a lot of people actually go and ask and receive questions about diabetes. So, we collected almost a whole universe of, or what are all the questions, keywords. Let's collect all the keywords that people are searching for. And that gives us a universe of information that people are trying to find on platforms such as YouTube or even Daily Strength. And so we need to have not only the most commonly searched conditions, but we also we need to have the entire spectrum, even something very rare. We want to know what people are searching for. We use those as keywords. And then we go to YouTube, use these keywords. For each keyword, we retrieve the top 200 videos that are retrieved by YouTube for each of those queries. And for each of those, we can collect video level metadata information. On In subsequent studies, we also collected video level features itself using Google Cloud Vision API. So we have video analytics, we have image characteristics. We also use NLP methods on the metadata of each video. Metadata will have things like title, description, topics, view count. The descriptions of videos are fairly rich, and we use that. I'll explain that next. We used a bidirectional long short term memory based method to quantify the themes. So our machine learning pipeline is a little bit like this. We use Google Cloud storage and data processing platform to get video level intelligence. And then the most challenging part of our method is we have to find input from doctors, from patient education experts, from public health professionals, to create an annotated data set that we can then use to build predictive models. And finally, we need a data analysis and visualization piece. That is what is given to all the doctors who collaborate with us. So we can just take this pipeline and then give our videos to doctors as sort of a prescriptive. Here, these are some videos that you can use in your daily practice. The video recommendations are contextualized and tailored to each stage of the disease, and that's the end goal of our what we are trying to do. So we have The video level analysis, we do object detection methods, we do shot detection, OCR, audio transcription of the whole video itself. We can do a lot of text analysis like readability, syntactic analysis. We've also used BERT-based models to identify themes and topics that emerge from the video metadata. We did some amount of sentiment analysis on the comments, but I've today I'm not presenting the features that derive from comments of the videos. So let me talk about the first step, very first study that we did. What we tried to do was first let's identify if somebody is looking for information on diabetes. Let's say you go to YouTube and you put in a keyword called diabetes. The top 10 videos that you get, how many of them will actually have content related to diabetes? And second, how much of that content will be actually medical content? And of course, third, then will this correspond to best practice guidelines? One could argue that the more popular the videos, there is quite a bit of maybe pseudoscientific or completely even scientifically misleading content that's out there. So our first goal is to find a method to assess medical terminology in videos. Can I at least have a filter that says that this video actually contains anything medically relevant? Now, of course, there is like that adversarial challenge where it's like, how to lie with statistics. We could use medical information and we can make misleading claims. That is a huge challenge in the misinformation space, but I will not address that. My very first question would at least be something where if I put a keyword for diabetes and I look at the top 10 videos, there will be a video which is miracle cure for diabetes in 24 hours, and that video probably is like number 2 in out of those top 10 videos, right? How do I filter those videos out? Well, for that I start with what is in the National Library of Medicine in the United States provides a guideline called UMLS, Unified Medical Language Syntax. UMLS is basically a dictionary based approach which talks about any medical information as a kind of a relationship between medical entities. So the relations can be entity can be a disease, and entity can be treatment, entity can be the relationship between. So metformin treats diabetes. That's a syntactic relationship. Similarly, something prevents something, something contraindicates something, something is a cause, something is a symptom. All these, we could consider that as a simply, in the simplest form, it's a medical named entity recognition. Right? So many of you are familiar with named entity recognition methods from NLP. What I have is a modified named entity recognition, but for medical terms. So it's an NLP. We've subsequently tried to, uh, I would say, extend our analysis to also consider images. What if I have a video that is about diabetes and that's someone is actually showing how to use a glucometer or how to take some medicine, and will that presence of a medical object help in some sense with patients' uptake of the medical information provided in the videos? That's a question that we've analyzed as well. But to start with, let's look at how we measure medical information in a video. And so this is first step. We used a bidirectional long short term memory. Now, I should say this question I have got from many times when I was presenting this work is, can't you use some BERT type of model? And for that, I have to say that this is a work that we started some years ago. I think now maybe it's possible to tweak a BERT based architecture and sort of superimpose a UMLS approach on top of BERT. We've done a little bit of that in subsequent work, but to start with, we built our own a bidirectional long short term memory method, which looks at basically medical terms as disease, treatment, symptoms. It's a named entity recognition method. So this is basically the UMLS. All these are semantic types in UMLS. So what are semantic types? They can be different groups. There can be body parts. There can be chemical, devices. There can be events, people, procedures. And what are some challenges? Remember that what I'm trying to do is I am trying to find named entity recognition using NER methods to detect medical information, how much medical information there is in videos. Now, the operationalization for the study, there are a lot of semantic types, but what I have are two issues that I have to grapple with. One is that this is consumer vocabulary of patient information, medical information. This is not named entity recognition where I'm using doctor's notes or clinical guidelines. That's the number one issue. Second, it's also YouTube context where it's not only informal, but there's there is sort of this whole context of maybe how medical information is provided to a completely different audience, considering that this is medical information for patients, sometimes maybe by other patients. So how do we consider all those nuances? We had to do a lot of evaluation. One is we compared the MetaMap, which is basically a UMLS based dictionary based approach. What are the false positives, false negatives that arise in both? Then we looked at other methods like conditional random fields, and then our BILSTM, bidirectional long short term memory. So the false negatives will be the boundaries of a phrase. How do we recognize a phrase? Other problems that we had to deal with are when there are medically irrelevant words in phrases, inclusion of these medically irrelevant words. And that required sometimes reannotation. So, again, this is thing where we found that we needed a lot of care with respect to annotation, and we had to do a lot of smaller experiments to make sure that our annotation and our approaches are like really it, um, representing information correctly. And the performance evaluation, the BILSTM approach was extremely good. So what it does now is we used we can detect medical terminology in videos. Then we did a second round of we worked with doctors, and what we have is basically we can use annotated data. We can have clinicians watch a video and say, is this medically relevant or not? And we can use the number of medical terms as a feature obtained from the BILSTM model. And we trained a logistic regression based classifier. And then we examined how the medically relevant information, how is it impacting popularity of video, the engagement metrics with videos, and so forth. So, of course, to cut a long story short, the most popular videos are not the most medically relevant videos. We don't need my analysis to tell us that. But what my method does is it helps us in sort of providing a guideline for establishing a threshold of these are videos that are medically accurate or at least have medically relevant information. And that's a best practice that social media companies can use building off of our approach. And then what is it that we have to do? Well, we have one part of the puzzle. We understand what is medically relevant or not. Second question is what makes people engage with maybe if medical information is kind of off putting for people. What is it that people want when they're engaging with medical content, video form, and social media platforms? So we consulted with patient education experts And there is a guideline developed by the American Health Institute for Health Research Quality, AHRQ, called the PMAT, Patient Education Material Assessment Tool. What it does is PMAT provides guidelines that say when a video information, when a video is understandable from a patient education perspective. So they're best practice guidelines. So what we did, we built an ML pipeline using co-training because it's very hard to get a lot of data samples. So co-training method, we used it as a human in the loop machine learning approach with video features and video metadata as two views. And again, we started with the co-training approach, but our objective ultimately is that this method can be scaled with much larger data sets if we can use co-training in combination with transfer learning. So that's our ultimate objective. Today, I'll only present one part of this analysis. And there are excellent examples of we can use co-training with transformers for videos and images. And this has been popular with action recognition, among other things. And that's the kind of approach that we try to do. And so our approach allows us for public health experts and clinicians to validate the model prediction as a sort of human in the loop AI approach. So, what then we can do is we can evaluate and compare patient education materials in written, audio, and video formats by considering content understandability by end users. So, the video data processing, we use object detection methods, we use short change detection, screen transcription, text detection. All these are different methods which we. So, videos are annotated independently with a lot of graduate research assistants and annotated with these PMAT guidelines. So, our co training approach basically considers the patient education guidelines operationalized. We use annotated data and built this co training based classifier. And since ours is a human in the loop approach, what we really have to understand is this is it's like an iteration where we have two classifiers. If the two classifiers are contradicting each other, one classifier produces high confidence label, another classifier produces low confidence label, that is when we need the human in the loop third annotator to resolve that kind of discrepancy. And this process is done iteratively till every video in the sample is labeled. Of course, there are some things that may be difficult to classify, and we have to evaluate and do more more experiments to understand what is going on with those ones. So, this is basically the the training ROC curves of co-training with a logistic regression, different methods. What we have to really pay very close attention is that what is the classification error by the number of iterations? How many iterations do we that algorithm have to work with? And also, can I look at my error rate with the number of labeled training examples? Now, there's other methods like active learning, where again, what we have to do is we have to look at how many iterations of the data do we have to uh, I mean, how much of a labeled data set will I need to produce high quality inference and so on? Similarly, those are questions I will have to consider as well. So, what about how sensitive is my error rate to the number of label training examples? Do I need very high number of labels, low number of labels, etc.? And then what are the expert interventions needed by confidence threshold? Because when there's discrepancy between the two classifiers, so this is like a multi-view classification problem. And again, this approach can be modified with sort of an ensemble method as well. right? So how many interventions are required by the confidence thresholds? And similarly, what are the classification error by these confidence thresholds? We have to look at all these very carefully. And so what's the end result? One thing we found is our algorithm, the precision at K is a measure from information retrieval. So as basically, if we look at what YouTube would rank videos in their top 10 rankings with the algorithm that how what predictions our algorithm generates, we find that the expert recommendation precision at K, the more number of samples we have, our algorithm is actually doing very well compared to human expert. A patient education expert watches the videos and rates them as understandable or not understandable. Our algorithm rates videos as understandable or not understandable. Our method was actually outperforming the precision at K dimensions with sufficient number of training samples. So that to us gives us confidence in our method. So again, we looked at these are the things the domain experts I should have put this before I showed the precision at case. So we are happy to report that our the precision at K measures showed that basically our method is scalable and it also performs well with even in terms of as a comparison with human experts and what they would predict. So this is a simple illustration of our approach. If we do a very simple keyword search like diabetes and get top 10 search results, how many of these would be recommended by a method? How many are not recommended by a method? And one can add an explainability layer as well. We can say it's explainable because of, and some smaller experiments which we did, will the confidence for a human subject, will they increase if we tell them why we recommended this video? And there's again a lot of studies that have done those kinds of work from a public health perspective and so on. So just a small set of questions that we can ask. So what are some implications? So how can I sort of use this approach? As I said, my objective is like an AI for social good. Right? So simple, if I consider like 2 by 2 matrix, if I have high understandable videos, low understandable videos, high medical information videos, low medical information videos, there's my method will simply provide a baseline by which there's at least like a lot of spam content that can be filtered out, and then there's some best practice videos that can be actually used for patient education purposes, right? So I think that's those are some like implications of our work. And as I also said, what we've tried to do is we've developed this library of videos using this user generated content, and this is our collaboration with a lot of healthcare organizations. We worked on multiple conditions, multiple diseases, and the first, what I presented are the first two studies kind of from our stream. But when we generalized this to COVID, we've generalized this to many other conditions where patient health needs, it can be contextualized to different stages of disease and so forth. The other problem which we are trying to understand is when we talk about recommended videos in any healthcare context, we've had a lot of conversations with the YouTube policy team. One of the things they said is very challenging is not just the credibility of medical information, but also the representativeness of medical information. In other words, if let's say someone is going to YouTube to look for diabetes related information, does it matter a lot if you get a lot of queries of authenticated medical information, but it's predominantly showing, let's say, a Caucasian male person talking about a specific set of lifestyle choices? Does the representativeness matter? the YouTube policy team's perspective is that that's also very important in terms of showing recommendations. So, what we have tried to do is we've used metrics methods from uh, machine learning, fair and transparent machine learning practices. So again, the challenge that we are trying to understand is that a lot of population is not really proficient in health literacy. So maybe they are likely to engage with health information in a better manner if they find that it's coming from people like them. So can we sort of assess representativeness of recommendations? So what then we did was to build on the previous work that we have done. We also used methods to detect age and gender using automated face recognition and age recognition and gender recognition methods, for which we also have a benchmark where we had people, research assistants, watch and annotate the videos, because algorithmic detection of face through face live, etc., is not always accurate. And so we are trying to build on the previous work that we have done by identifying characteristics of people uh, that are featured in the videos, characteristics, the demographic characteristics of users who are subscribing to the videos, which we can only get at an aggregate level. We can also look at the readability index and the health literacy level of the content creators from the metadata of the video channel that posting the video and so forth. So there's a lot of these are all the information that we can try to get. And so what we are trying to understand is what is the level of representation and diversity of actors at the video level. Do certain groups that are belong in the United States have protected attributes like race, gender, ethnicity? Are there an underrepresentation of certain characteristics? Do videos played by certain group of actors, is there more popularity, or is there some sort of a popularity bias in the representation of videos and so forth? So that's the next question that we were trying to solve. So what we do understand is we can measure for each video what is the gender proportion of the video time that is by the gender of the actor. We can look at the visibility of the face. Then we can also look at a lot of the network that the channel is embedded in by looking at video subscriber, a lot of network science related metrics. And then very simple kind of analysis that we can do is, well, the simplest analysis that I am presenting here is we do find that there's videos that have feature male actors, there is a higher visibility, but we don't find a huge impact of attributes and individual basis. So they, in other words, it's less of a bias directly on race or gender or age, but there's like what we call significant interaction terms. So if we look at characteristics together, so we could argue that certain race and certain gender, there is definitely a skew when we look at representativeness by those more granular categories. And so that's the next set of things that we are trying to study. We look at videos, we can do frame by frame analysis. We split the videos into frames and apply face recognition methods and count the number of frames. And we look at uh, again facial detection algorithm. We do our own as a baseline comparison. We have done our own annotated data and do manually annotated data comparison with how algorithmically classification of race and gender improves, and apply that to what I have already shown previously. So once again, our method basically is combining uh, methods from healthcare, methods from public health, from patient education. We are looking at video level analysis. We are looking at frame by frame analysis. We do image analysis. We also have done audio analysis of this transcription coefficient, audio quality, and other measures. We are also looking at the metadata of videos. So we use NLP methods. And then we've combined some of these in a human in the loop method and trying to push the frontier by having co-training in combination with, I would say, the transfer learning, use bird-based models for thematic composition in videos and so forth. So that's in a nutshell some of the work that we have tried to do. So we used methods like deep face for ethnicity recognition, facial recognition, and so forth. So can we consider all a consolidated maybe fairness or representativeness score? Can we look at like all these reverse causality between popularity and representativeness of videos? As I said, individually, these protected attributes by themselves, we don't see that much of impact, but there is a significant interaction effect, which is interesting, and that's subject of further study by my research group. So these were some of the things that I have studied, and I think I'm kind of ran through my presentation a little quick. I have a couple more minutes, but I think I can stop here and take any questions.
Thank you, Anjana, for that very interesting talk. Uh, are there any questions to the speaker?
Hello, good morning, and very nice talk, ma'am. Ma'am, I would
Okay,
like to
okay,
know
Thank
that
you.
uh, as you have told, do you do some early filtering of videos also, like if the source is a recognized one, or if the I assume if the video is longer, then it has more chances of being a good video, because exciting
Mhm.
videos are usually short. So, do you do this kind of early filtering also?
Yes. Yes, we don't want to filter things out from our analysis. We want to use whatever you described as features in my analysis. So, we want, in other words, my objective is to use an extensive set of features. So, the length of the video is a feature as far as I'm concerned, right? What we also try to do is the definition, HD versus like low def, for example. That's also a feature in my analysis. And the third thing that you mentioned is actually very interesting. Is this a credible source of medical information? So, one of the things that YouTube actually introduced in the last 1 year is that they are trying to provide a check, like a blue check mark Twitter has, saying this is a provider of authenticated medical information, right? But what in our group we did some analysis, we were able to independently audit, and turns out that YouTube's method is actually very good at identifying credible sources from within the United States. But from the United Kingdom, there was videos from National Health Service that are not labeled as authentic medical information. So our method was, in a sense, we had more of a finer classification than YouTube's default method. But yes, thank you for that question.
Hello, very nice talk.
Hi.
I have two questions. One is
Mhm.
many of the informative videos does not feature an actor. So how does those videos enter your pipeline? And the second one is the results will change depending upon which country server you are searching. So how does that
Yes.
also come into your pipeline? Thank you.
Yeah. So great point. So first, my first few studies are not looking in the presence of actor or no actor. So I can do all my analysis without considering any actors at all, right? The second question part is that, let's say there are some videos that are, there's actually a lot of medical education videos like surgery instruction. Those videos are posted on YouTube. Uh, and so those are very high from a medical information perspective. but they're not understandable necessarily from patient education perspective. So my method already addresses some of those issues. Um, the the thing about face not being visible, we did not find it to be a huge bias in the videos that we looked at, but subsequent studies, maybe that is a question I have to consider. The So far we did not find that to be a bias, right? And the fourth question you asked me is about the sensitivity to the server. In fact, YouTube videos, the results are also very sensitive to your prior history. So, for example, a collaborator of mine, when she was having a baby, she used to check for videos on gestational diabetes. So later on, if you go to YouTube and put any diabetes query, if she were to do that query, then you'll get all the gestational diabetes related information. So it's very sensitive to search history. So what we try to do to solve that problem is try to simulate, have a lot of multiple environments using our supercomputer facilities, parallel computing facilities, etc. We tried to recreate or collect the data from as many different machines or instances. And that's one way we could solve the problem. So I don't know if that answers all your question.
Okay, very nice talk. Thank you. Now, my question is from the language side, and I do see that you are, catching a lot of surface signals on the language side. My question is on the deeper semantic signals. So
Yes.
we have seen that in sarcasm, humor, fake news, these phenomena we
Yes.
call it rare language phenomena, and
Yes.
they have particular characteristics with respect to their semantics. The other
Yes.
point is that I think one should use like attracts like kind of phenomenon here.
Yes.
The cluster of non-reliable entities should
Yes.
have a smaller distance with a new non-reliable entity. Yeah.
Yes. Thank you for both those comments. So the humor, sarcasm, so far since we didn't look at the emotional support from the videos or something like that, it was less of a challenge. But I have also studied YouTube for how people, I would say, like, there's a lot of climate change related misinformation on YouTube. So I've done some research on those topics as well. So what you mentioned, the sarcasm, that humor, the even pessimism, those are themes I had to deal with using NLP when I studied climate change misinformation. Not so much in these studies where I had to do study healthcare, use of YouTube for healthcare. The second part was what you refer to is called homophily in the social networks and the network science community. The like attracts like. One way to do that is to do maybe a network level analysis of the channels, because we see that a lot with Twitter data, that people who are engaging in misinformation, they're very tight clusters. And it's essentially, we can almost, we don't even need to look at who tweeted what. We just need to know how they're connected to other people to predict like the types of misinformation. So I haven't done that with this studies, but I've I'm familiar with that, and I've used it in other sort of. There's more analysis to be done. Certainly, I have to agree with that.
Thank you, Anjana. Yeah, another question is there. Yeah. Yeah. One second. One question. There is an online question. Is
Okay.
guidelines prepared for this research is only for English medicine or for all kinds of medicine?
So far, only for English, because the challenge that we will run into is translating this UMLS type of syntax into maybe Telugu or Tamil or something like that. and that would require some annotation. And just from my limited, I studied in English medium when I was in India, but I would notice like the chemistry terms in Telugu, for example, will be like something dhatu for some element, and I or metal or like so. I think that would be a substantially larger challenge. But I do hope that we can take this work and translate it to maybe Indian languages, for example. That would be really wonderful. But yes, so far only English.
Actually, it is, if I understand the question, it's not about
Mhm.
the language, but it is the alternate medicine, like other kind of Ayurveda,
Oh, right.
homeopathy kind of thing, not
I,
like
s-
just allopathy. That is the question, I guess. Not
I
local
see.
language.
Yes, thank you.
Okay.
Oh, I see. I think I misunderstood. Yes, our guidelines are very much for the English medicine, not for
Okay.
because UMLS is rooted in a certain way, on the patient education guidelines are very much Western medicine guidelines. If there were a provider, like if there's a national body that does homeopathy or traditional medicine Ayurveda guidelines, then we can do the same thing, right? We can get annotated data and we can build a machine learning based classifier. But I don't have that the training, because I'm just using these frameworks like UMLS and PMAT, which are developed with a Western medicine perspective.
Okay. Thank you, Anjana. There is another question here.
Yeah. Great set of problems. This is PK from Triple IT Hyderabad. I have two questions. One is on the real-time nature of the solution. The other one is the platform that we're studying itself. So the first, elaborate on the first question, real-time nature, is meaning all the algorithms, methods that you're producing. I mean, how quickly can we get it so that these videos are, let's take, taken down, all of that, right? Because that the effectiveness of the solution is going to be on the real-time nature.
Yes.
The second question is the results, the graphs that you showed, which video is more popular at a given point in time or a topic,
Mhm.
all that. It could be that YouTube is
Mhm.
doing something which we don't know, right?
Yes.
How do we as researchers keep that in part of, because our results may be completely
Yes.
driven by only the YouTube algorithm, which they could have changed just before the month that you collected the
Yes.
data, right? So what are your thoughts on
Yes.
these two problems?
Yes. Great questions, both. Thank you so much. So, first, the nature of solution is actually very complicated. So, let me start with COVID. One of the things we saw is in March 2020 in the US, actually, we were told not to wear masks because the thing was, I think the masks were in short supply. So the health authorities were trying to save the masks for the emergency responders, right? So that's, to answer your point, it's that the nature of the what is misinformation, what is credible information is constantly evolving. So one challenge I will face is I am treating the world as static in my analysis, right? But the second thing I can do, what I can do is I can look at YouTube's policy changes as a, I would say, as someone who does like causality and causal inference, that the before and after policy shift, if I can measure the type of healthcare information or the amount of credible information and see if something has changed, that gives me a way to evaluate how sensitive my methods are to like this nature of the fact that this is a very fast moving sort of world. So second, to answer your second question, the black box nature of the YouTube algorithm, what we've tried to do, I think, is we've also collected the rank of the video. Is this like in the top 10? Will the video show up in top 5, top 10 rankings? So we can take different splits of the data to see if it's sub top 5, top 10, etc. And it's basically like a censored model from a statistical perspective. Do I have like a censored regression? So what's the impact of medical information on popularity of the video, I can consider censoring effect from YouTube's ranking, right? So this is like it's a statistical exercise, but that will give me some effect of, I can at least get the magnitude impact of some shift that happens because of YouTube's policy. Right? So that's one way to get some benchmark understanding. I do agree that, I mean, we don't have a perfect world where YouTube will allow me to run these online experiments. We've tried to talk to YouTube policy team many, many times, and they're happy with our work, but they didn't let me do any controlled experiment or anything like that. So, in the absence of a large scale experiment with YouTube, we have done some user studies, and I think that we can do some lab experiments to try to reproduce. But there's necessarily some bias. That's, we can use statistical methods to correct for that bias, in my opinion. But there is some bias will be there.
Thank you.
YouTube has all these rabbit holes, right? I mean, you start
Yeah.
viewing something that gives you more and more of the same. And
Yes.
that has a huge impact on whatever you do. So is there any way you thought of countering for this? Of course, you can ask YouTube to stop doing this, but that's not
No.
likely to work very well. But is there anything else you can do?
Yeah, what can we do to counter the rabbit hole? I would say, part of the thing is providing this kind of a label for, is this credible information? That's one way to counter the rabbit hole effect. Others provide some context to, this video is recommended because it's understandable, let's say. So some of those will, the rabbit holes are caused because of this, it's like this Instagram or TikTok type of a thing where video, the watch time, the video view time is the only metric, let's say. And so when somebody's watching a video, if they're optimizing on the view time and they're showing other videos that will keep you down that engagement, uh, like a rabbit hole, if you will, that will result in what you just talked about, right? So I would argue that trying to find some credible information, credible sources of information, etc., will reduce that rabbit hole effect because we are providing some context to the user, and instead of just manipulating the viewership based on a view time type of a thing. But that's just an incomplete answer. I think the problem is far bigger than what any individual researchers can hope to accomplish. And so we've only tried to manipulate our conditions by looking at popularity and looking at basically tweaking sort of different indicators of some types of videos are more likely to result in rabbit hole compared to others. So I think that's the manipulation check that we can do.
I have a question. I think you partially answered it. So what is credible information and what is misinformation? So from your responses so far, looks like the government position is credible, but some experts may have a contrary view, and even two groups of experts may have contrary views. So forget the trolls and other people. But if some agency is saying something and some researchers who are working in that area for 20 years, they say something contrary. So what is credible?
Yes. What we found, again, that's why I said I've studied this problem both from healthcare. I've also studied this problem from the environmental perspective, like studying misinformation, credible information relating to climate change on YouTube. In my opinion, credibility is much harder in the climate change because it's much harder to take those kind of, the IOC reports, which are very nuanced, and turn it into one simple like soundbite. Here, my measure of credibility is a very simple measure. It is measuring, does this have medical knowledge? Is this understandable? If there is a contradictory opinion between two experts, my method will say both are credible information, right? So because I have a very deliberately simplified image, I've taken a very simplified approach to what credible information is. But again, as I said, it's much harder in the context of climate change and other types of misinformation to establish that credible information versus not credible information.
Thanks, Anjana. We have one last question. Yeah.
Yeah. Thank you for the great talk and continuing from the ongoing discussion. So, how do you differentiate between right and wrong information? So, maybe there is some medicine X which is good for diabetes, but the video may say that it is bad or detrimental for diabetes. So you are using static features from the videos to classify credibility or misinformation. But do you think you should also look into the contents or like dynamic features in the video and try to extract the triples that are present, UMLS type triples, and you can try to match those triples with the UMLS to say. So maybe some video may have medical content, but is that medical content correct or not?
Yes.
Do you think that would be better? Uh,
Well, I think the simplest answer I can say is that if National Institute of Health gives me another huge, some 2 or 3 big grants, then I'll have the resources to study all these questions. But yeah, I mean, it's just such a fascinating topic. There's so many questions to study. So hopefully, I'll get funded for more future studies, and I can look at all these interesting questions. I do agree that my method is static, and maybe more dynamic syntax will help. But it's a great question. Thank you so much.
Yeah. Thanks a lot, Anjana, for that very interesting and informative session. Please give a big hand to Anjana. Yeah.
Thank you.
Thanks again. Thank you.
Thank you.